This is problem 4.6, and we want to calculate the moment of that force respect to point A, which is this point right here, of this force. Therefore, the definition of moment is as a vector, the distance times the force. Which distance? The distance that goes from the point where the force is applied. So it will be A to B cross F. So we have to find those two vectors in order to do the calculations, right? As we see, the vector AB is from here to here. This line over here is parallel to Y, so it will be negative 600 in J millimeters, right? Or, which is the same, negative 0.6 meters, right? Let me put the J before. J in meters, right? So, and this is a vector, and this is a unit vector, right? So we got this vector over here. So, and we have to get F. F as a vector has a magnitude, which I think is given. Yes, F, the magnitude of F is 100 newtons. Therefore, we have the magnitude times the direction. The direction goes from B to C. So it's a unit vector that goes from B to C. How do we find this unit vector? You recall that a unit vector is the vector divided by its magnitude. So we have to find the vector BC. How do we find the vector BC? Either we subtract the coordinates from C minus the coordinates of B, or we go and cover the same distance from B to C, but following each of the axes. So for example, I will go negative 0.4 meters in X, in Y I go 0.6, and in K I go 0.2. And that divided by the magnitude of that vector, which is 0.4 square, 0.6 square, 0.2 square. So that's my vector. So if I multiply that by this force over here, I get 100 times negative 0.4 in I, 0.6 in J, 0.2 in K, and I have this, the value of this square root. Please remember to keep, I will write 4 decimals, but keep as many decimals as you may in the calculator so that you can have least rounded error. So when I do this multiplication, which means 100 times 0.4 divided by this number, I get the value for the force. And the value for the force is negative 553.3 I plus 80.2 J plus 26.7 K. This is in newtons. So I never forget the units. Is very important because it actually gives us the consistency of the problem. So we were able to find R and we were able to find F. So we have both components that we need to calculate our moment. The moment then, respect to point A, will be equals to 0.6 times this. I could do it as a matrix, or I could do it just as a distributed multiplication. And you do it as you feel more comfortable. Since I have done many problems, so this is negative 0.6 times cross negative 53.3i plus 80.2j plus 26.7k. So you can write that as a matrix, as we have done several problems. Since this vector has only one component, I could just do the distributed multiplication of these two vectors. Always remember that I cross j is k, k cross I is j, and j cross k is I, and if I go in the opposite direction, j cross I is negative k, and so forth. So if we use this is in the positive direction, and this is in the negative direction. So, for example, here I will have j times cross I. So j cross I will be negative k. With this negative and this negative becomes negative k, right? And this is negative. This value times this value gives me negative 32.1 k. Then j cross j, this is a j, is 0, and then j cross k is positive, right? But since this value is negative, give me a negative value. So it's j cross k given a negative value of I. And this is the result. And the units of this moment is newtons per meters. I always write it in a different box so that we get the result. I write it in order. I minus 32.1 in K newtons meters. So we were able to calculate the moment respect to A. As you see in the slides, we could calculate the moment using point B or using point C, because since F is a sliding vector, right, I could use any point of the line of action of this vector to calculate my moment. So I could have used to calculate moment with respect to A, R, being R, A to C. So I invite you to do that exercise. Instead of using AB, use AC, and you should get exactly the same value. So this was the first question of this problem, and the second question is moment respect to B. Moment respect to B will be the distance times the force. But as you see, the force is applied at B. So the distance from B to B is equals to 0. Therefore, the moment respect to B is equals to 0. So anytime we don't have any distance, we have no moment. And this is the solution of this problem.